Hi Kate. What a pleasant surprise to see you here. May I join you?
Yes, Jared. Of course you may. It is always nice to chat with an old friend.
Excellent. So, are you still studying statistics?
Yes. I am indeed. In fact, I have an important exam tomorrow.
Oh. Would you like to try and teach me? I'm always keen to learn something new.
I will try my best. The exam is testing proportional hazard models. They are a type of survival model. By this, I mean that they attempt to estimate the time until a hazard occurs.
Sorry to interrupt, but what is a hazard?
That's okay. I should have said. A hazard is simply an unwanted event, such as a machine breaking down. For actuarial modeling, a hazard is often a death. Hazard models subdivide the sample based on variables called covariates. Typical covariates, when modeling mortality, are each person's age, gender and whether they are a smoker.
This is very interesting. So, if you know a lot of information about me, can you predict when I'm going to die?
It doesn't quite work like that. Covariates are useful because they divide the sample into smaller, more homogeneous groups. However, if the groups are too small, issues arise.
That is reassuring. Is there a formula for the proportional hazards model that you need to remember?
Well, actually there are many possible formulas, or parametric models, that would produce proportional hazards. Luckily, there is only one that I need to remember. It is called the Cox regression model. The model has two components. The first is called the baseline hazard. The other is an exponential term used to produce different hazard rates for each individual based on which covariate groups they belong to. For instance, let's think of a basic model with only two covariates, gender and smoking status.
So, overall, we want to calculate 4 different hazard rates. One for males who smoke, one for males who do not smoke, and, likewise for females.
That's right. We might take the baseline hazard to be males who do not smoke. In the exponential term we would have 2 vectors. One that indicates the value for the covariates. We call this vector Z. The baseline group, Z is 0, 0. In our case, males who do not smoke would be 0, 0 and females who do smoke would be 1, 1. The other vector is, called beta. Beta is like the slope coefficients in any regression model. If the beta value is positive, then its corresponding covariate produces a higher hazard. In our case, we would expect the beta value that relates to smoking to be positive, because non-smokers are in the baseline hazard and we expect that smokers would have a higher hazard rate.
Wow! This sounds like a very powerful model. I am curious, how do you estimate the values for beta?
I am glad that you are so interested. Estimating beta is not too difficult, however the details may be too much to explain in a donut shop. Basically, it involves maximizing a partial likelihood function. For each hazard that occurs in our sample, we record a contribution to the likelihood function. It is based on how many lives are remaining when the hazard occurred. The partial likelihood function is the product of all the contributions. Is that okay? Is there anything else that you would like to know?
Yes, that is clear. Thanks. I just have one more question. Why are they called proportional hazard models?
Good question. If you take 2 lives with different covariate vectors, they will be in the same proportion at all times. This is useful because the ratio of 2 different hazards is simplified. The Cox model is popular because hazard rates are never negative and it conveniently gives a linear model for the logarithm of hazards.
Thanks. You seem to know this topic very well. I am sure that you will do well in your exam tomorrow.
No worries. I think that explaining the topic helped make it clearer for me.
So, are you going to buy any donuts?